We're AI Camp. The aim of us is to learn and practice AI from anywhere at any time with live webinars, workshops, courses in 15 different countries with 50 plus cities and with over 100,000 plus developers in our network. So today we're going to be listening to a session on training and deploying models at scale with BigQuery ML by Polong Lin. Just a few kind of housekeeping issues. We have organized today a Q&A tab in the bottom of the Zoom screen. So we will have a 20-minute Q&A session at the end. If you have any questions, please put them in the Q&A tab. There's obviously a lot of you here today, so it would be best to keep all the questions in one place. As well as this, if we run out of time and we can't get through all the questions, please add the questions into our Slack channel. The Slack invitation link is here. We have a channel MLOps20, and you can ask questions following up in there, and the speaker should be available to follow up with those after the session has finished. We are recording the session. I can see some of you have been asking about that in the chat. This will be the link, but search AI Camp on YouTube and you should be able to see it come up there. And please follow us on Twitter. Also, feel free to join the Slack channel that we have. And this will be a way that you can keep involved with the network after the event as well as during. So that's all I have. And I'll give a quick handover to our speaker today.
Great. Thank you so much, Christina and Bill. Hello, everyone. My name is Polong Lin. I'm a developer advocate for Google Cloud. And I'm just going to begin by sharing my screen here. So hopefully everyone can see my screen. Should see training and deploying models at scale with BigQuery ML. And all right, so let's get started. Just a little bit more background about myself. My focus is on helping developers, whether it's data scientists, machine learning engineers, data analysts, be able to work with Google Cloud in terms of data science and machine learning. So that's kind of my focus at Google Cloud. Today, I'll be talking about kind of two pieces. They're both kind of intertwined. The first is around training and deploying machine learning models at scale using BigQuery ML, and also how we can use BigQuery ML from Jupyter Lab on Google Cloud with what we call AI platform notebooks. So be kind of a short split between the two. So you may not all be familiar with what Google BigQuery is. So it is the enterprise data warehouse on Google Cloud. And that's where a lot of enterprises, businesses store a lot of their data on Google Cloud. And so some customers end up storing, gigabytes, terabytes, petabytes, sometimes even exabytes of data on Google BigQuery. And so it's a massive, fully managed data warehouse with security and encryption built in. And it's just a lot of fun to work with. So before kind of talking a little bit too much about BigQuery, I always love to give a bit of a demonstration of what BigQuery is actually like on Google Cloud. So hopefully everyone can see my screen now. I'm now in the BigQuery UI or the BigQuery console, and I am here on the Google Cloud platform itself. And as you can see here, I have a bit of an editor, right? So here's where I'm writing my SQL statements. Down below is some sort of like a console or a UI showing my data. And on the bottom left-hand side, I have some data sets that I might have stored in the data warehouse within my project. So my project is Polong BigQuery. And in this public kind of data set that's available under BigQuery public data sets, here's this Wikipedia public data set. And what this data set shows is for 2015, 2016, 2017, we can actually look at a bit of a preview of the kind of data that it includes. So for example, in these data sets for Wikipedia, for every date and for every hour, what this data set contains is the name of a particular Wikipedia article and the number of views that it's had. So this data set in just 2018, for example, if we look under details, it has 2.25 terabytes of data stored. And so what we'd like to try to do is let's try to use BigQuery right now live and see how quickly it can kind of query this amount of data. So I prepared this little query here, and because the pandemic is top of mind for everyone these days, why don't we take a look at Wikipedia articles that contain in the title something similar to the word coronavirus. And we'll look for all the dates between 2016 and 2020 and all the English articles. We'll do a group by, and we're going to sum up all the page views. And let's just try to see how quickly this can run. So you may have noticed on the right-hand side, when you write in your SQL statements in BigQuery, it actually tells you how much data is going to be processed. And I just missed it, so I forgot the number, but it's in the terabytes. So we'll come back to that once this is finished querying. And it should take about 20 to 30 seconds, usually towards 30 seconds. Oh, it's okay. It's actually finished faster than that, which is great. So this query processed 10 terabytes of data just now in the 17.5 seconds. So here it kind of like looked at just a subset. So it's 2.1 terabytes of data, but still in 17.5 seconds. And what do we see here? So across all these years from 2016 to 2020, you see the 2019, 2020 coronavirus pandemic had 18 million plus views there, followed by coronavirus and so on. But what might be interesting is when did these views kind of become, when did these views of Wikipedia pages spike in terms of the month? So I have another SQL statement down below just to see, oops, I just ran that by accident. Let me try to comment that out and uncomment the query that I have below here, run that. So what this one is doing is just simply taking a look on a month-to-month basis to see which month did we really see a spike in Wikipedia page views. So we'll let that run for a couple more seconds to see the results, to see which month did we actually see a big spike in coronavirus page views. And we'll see here down below, from 2016, and this is the total number of page views for that particular month. So it starts around 20,000. And there are, different types of coronaviruses out there, but we really see this big jump around the beginning of this year. So 2020, January, February, March is when it really hit a peak of 64 million page views. So that's kind of being able to see that kind of trend and how that changes over time. But as you can see here, it's processing quite large amounts of data in a very, very short amount of time. So this is BigQuery on Google Cloud. And for those of you who don't know, BigQuery kind of evolved from an internal system at Google because it came out of a problem of dealing with quite large data at Google as well. And so this is kind of the externalized version for anyone, for anyone to be able to use on Google Cloud. If you were to try to do some back of the envelope calculations on how many disks and cores you might need to run a query like the very first one I just showed you, given typical read times and so on, you might need something like 1,000 disks and 3,000 cores to be able to essentially run this query yourselves using standard disk and cores. But the idea here is you didn't actually have to experience that at all. It happened all behind the scenes. So the 17 seconds or the 21 seconds it took for you to run something like this, it's all done automatically for you. It's scaled automatically for you. So that data is being processed behind the scenes so that you don't have to worry about scaling up your infrastructure at all. And that makes things a lot more simple for you to focus more on the insights from data rather than on building up the infrastructure around setting up your data pipeline, essentially. Just a quick note on how BigQuery works in the behind the scenes. So BigQuery splits storage and compute as completely two distinct parts. So storage is where you host or where you keep your data. Compute is when you're actually doing the queries and trying to do your data processing. So they're separate and they can each independently scale kind of on the fly. And it's incredibly fast in which how it can scale up and down as needed. And of course, as a data warehouse might be expected to behave, you can have streaming data coming into BigQuery, you could have CSV files being loaded into BigQuery and so on. And of course, you have client libraries. But the focus of this presentation is not just on data processing with SQL, it's more on machine learning at scale with BigQuery ML. So if you imagine what a typical machine learning workflow might be, so as I mentioned, you might have streaming data or data coming in batches into your data warehouse, so like BigQuery. And you might be doing your data processing there. But then from there, if you want to train machine learning models, you might then have to export your data outside of your data warehouse in order to train your machine learning model, that could be in Python, R, or some other language or framework, and then you have to deploy your machine learning model. But for each of these, they come with their own issues. So for example, data governance, the data that you've exported out of your data warehouse is only a snapshot of what you have in the data warehouse. So how do you make sure that continues to update appropriately in your exported data? And then managing your machine learning model training as well. How do you manage your resources there, making sure you can scale up to train your models? And then finally, deploying your machine learning models. Where can you actually host your models is yet another question. So these lead to complexity and ultimately some costs as well. So the idea here is, given a resource, given a tool like BigQuery, what if you could do this all directly within BigQuery to train and deploy machine learning models? So the way that BigQuery ML works is these kind of 4 overarching steps. Number 1 is as you would have for any machine learning model, you select your training data using SQL, and then you can create your machine learning model, specifying what model type you want. You can evaluate your model and then make predictions using the model on new data from BigQuery without needing to leave the BigQuery ecosystem there. So as an example, let's say you have some data on BigQuery that looks like this. So this is the New York City taxi cab data set, and it's 129 gigabytes in size. So lots of rows of data. And you can see, for each row, we have a taxi cab ride. We have the pickup date, drop-off date, pickup location, drop-off location, and so on. So what if we could take this data and try to predict how much a taxi cab might cost in terms of dollars based off of where they get picked up and where they get dropped off? So in a typical kind of SQL statement, just to look at the data, just to set the training data for a machine learning model, you might do a select statement on the fare amount, the pickup location, the drop-off location, and then maybe even the number of passengers who are on that particular trip. Now, just by adding a couple more lines of code, you can now train a machine learning model. So here you can just add in create or replace model. So your data set in your project, the name of the model, whatever you like to call it. And then you input 2 things. Number 1 is what you want to actually predict. So in this case, the fare amount of the trip. And then number 2 is what model you want to use. So for example, in this case, linear regression, because you're trying to predict a quantitative variable, so linear reg there. So it takes a short amount of time to create the model, depending on your data and also depending on the model that you're using. But then afterwards, you can evaluate your model using this syntax here, ml.evaluate, directly on this model that you've created. And you don't even have to worry about hosting your model afterwards. It gets hosted automatically for you within BigQuery. So you can simply use ml.predict using the model on a new data set, and there you have it. You would be able to train and deploy and make predictions using your model directly. And I will show you a demo of this in action in just a moment. But you might be wondering, outside of logistic regression, what are some other model types that are available with BigQuery ML? We have classification model types like logistic regression, deep neural networks, XGBoost, and interesting enough, there's also AutoML tables. So if you've heard of AutoML tables with Google Cloud, the idea is you can input the data and AutoML will try to create the best possible model for your particular task, for your particular data set. So it could be a classification model kind of trained via AutoML, or it could be a regression type as well. So under regression, we also have AutoML here as well, in addition to XGBoost for regressors, DNN, linear regression as well. So AutoML is just a lot of fun to be able to work with and try to beat, which is kind of sometimes quite difficult too. Other model types, you have k-means clustering. You can do demand forecasting with time series forecasting. And then you can also create recommendation systems using matrix factorization. And then finally, you can import TensorFlow models. If you've built those models outside and you want to import that to run on data on your data warehouse on BigQuery, then you can import your TensorFlow models there and run that on your data. Here's some examples of BigQuery ML used, which I find is always kind of inspiring. Fellow coworker, Felipe, created this to predict the trend of various languages on Stack Overflow data. So using a time series forecasting model called ARIMA and on BigQuery ML, he's forecasting the different trends for different languages like Python, JavaScript, and so on. You can really kind of see how Python at least is projected. So the projection is in the gray area under ARIMA predictions, Python is projected to continue to increase in popularity. Popularity being the number of Stack Overflow posts with the Python tag over time. Another one, this is an article I wrote around how to build a recommendation system on e-commerce data. So for example, if your data for your retail website, you have visitors coming in, and for each of these visitors, they're looking at a particular item on your website, and based off of, let's say, Google Analytics, how long they're spending looking at that particular item. So we have this particular visitor in their session, they've looked at this particular item, it's a product SKU, and then the session duration in terms of seconds or milliseconds, whatever you like to look at. So you could actually build a recommendation system using this kind of data. And by using BigQuery ML with matrix factorization, you can actually create recommendations for each of your visitors. So as a follow-up, you could send emails and say, oh, we noticed that you were interested in XYZ. So you might also be interested in ABC products as well. So if you're interested, take a look at this article online. And as I mentioned, you can also import TensorFlow models into BigQuery. So in this particular example, using TensorFlow to predict whether or not these articles are from Hacker News, New York Times, or TechCrunch. So for example, this guy just found out how to bypass ad blocker. So that'd be from Hacker News, New York Times, or TechCrunch. Or fairies, witches, and supply and demand. Is that from Hacker News or TechCrunch, or could it be from New York Times? So creating a TensorFlow model outside and then importing onto data that's stored on BigQuery, you could make your predictions. So you import using the model type TensorFlow. The model path is a saved TensorFlow model on Google Cloud Storage, and you can make your predictions there to try to predict which one it is actually coming from. So this one is unlikely partnership in-house gives lawmakers hope for border deal, most likely from New York Times, as an example. Okay, and we've also seen other ways that BigQuery ML have been used. So in kind of competitions, in a very limited competition time, so of 1 or 2 hours, we created this little competition just to see if people can predict visitor behavior, try to predict if an item is going to be added to the cart in a cowgirl competition. And we had lots of teams come in and try to compete in this very short duration of 1 or 2 hours. And so we had 10 teams of people. And at the end, we then revealed the results of AutoML compared to each of the human teams. And what we found was AutoML you can train it at different kind of tiers, I would say, or a different number of budget hours at 1 hour, 2 hour, 8 hour, 4 hour, 12 hour, and so on. So we trained AutoML, and it turns out AutoML, without having that human domain expertise, and very quickly it was able to create these models and that outperform humans essentially. So that was quite interesting. It's all done within BigQuery ML as well, which makes things a lot easier. So the way that AutoML training works is you have your model that you're going to set. The input label is what you're trying to predict. The model type is AutoML regressor if you're doing regression, or AutoML classifier if you're doing a classification task. You can set the budget hour, so that's the maximum number of hours that it will try to train AutoML for, and then you simply select the data that you want to train on. So it's very similar to the linear regression code. It's very easy to use. So switching gears here, so some of you may not be as comfortable working in a UI like the BigQuery console UI. So some of you may be more familiar with working with notebooks. So with notebooks, you can work with Jupyter Lab on Google Cloud using what we call AI Platform Notebooks. So that's our term for this. And with BigQuery data, you can also, of course, use client libraries like the Google Cloud BigQuery Client Library to be able to interact with the data sitting on BigQuery as well. So in this particular case, you can set, so you can import the Google Cloud Library, import BigQuery, set your project ID, initiate the client, run your SQL statement here. And this can also include your BigQuery ML statements to be able to train, evaluate, and also make inferences from your models. And then finally get results and even export that directly into a pandas data frame. And there's also client libraries for R as well. So the way that AI Platform Notebooks works is that you can create these new instances. And for each of these new instances, you essentially have a Jupyter Lab instance in the cloud that you can access. So here I've created one for R. If you want to use R with Jupyter Lab, Here's a different one for Python. And as you can kind of see on the right-hand side, you have region, you have machine type, and GPUs. So depending on your particular needs, you may want to scale up those machines or scale them down or have them closer to your particular region. But just to note, for these kinds of queries where you're interacting with BigQuery, in that case, the processing is done on BigQuery. So that's where a lot of the processing is done. So within the Jupyter Lab environment, you would just be running your Python code essentially. So in that case, you may not need to have a particularly large machine type for AI Platform Notebooks. And a little bit more about AI Platform Notebooks. It's the enterprise managed Jupyter Notebook kind of experience, that service on Google Cloud. Use Python and R. You can install any kind of data science or ML libraries as you need to, but it's also pre-installed for you as well. And as I mentioned, you can also increase the number of number of CPUs or the amount of memory that you might need for your particular needs. So a quick kind of demonstration here is, so here I'm in the AI Platform Notebooks interface. So as you can kind of see, we have this kind of blue bar at the top that shows Google Cloud Platform. But if you open up the hamburger menu on the top left-hand corner, you can see of all the different kinds of services. So you can see under storage and under networking and so on. AI Platform Notebooks falls under, scroll down here enough, artificial intelligence under AI Platform and then notebooks. But there's a number of other different services that you can explore that I won't go into for this presentation. So I've already created this instance here. So I'm going to open up here in a separate tab. So this is Jupyter Lab on Google Cloud right now. And as you can see, I can import libraries as I need to. I can install libraries as I need to. And you can also use the BigQuery magic to be able to run SQL statements directly within a notebook. So if I run that, I can actually have that outputted directly into my pandas data frame as well. So it interacts quite seamlessly between BigQuery and these Jupyter notebooks as well. So that makes things a lot easier if your data is sitting in BigQuery and you don't want to have to export it as some sort of CSV file or whatnot. You can do that directly by integrating using the BigQuery package there. And as you can see, here I can do any kind of exploration. I'm not going to go into this code. It's more of a particular use case with liquor sales. There's a public data set on liquor sales at a wholesale level. And so, going through lots and lots of code in both Python as well as BigQuery ML to be able to understand this particular data set and how, for example, a business might be able to leverage something like this. So this is Jupyter Lab on Google Cloud with AI Platform Notebooks. And just coming back here. So if you're interested in trying to explore AI Platform Notebooks for Jupyter Notebooks, or if you're interested in trying to explore data sets just with SQL, or even try to train your own machine learning models, there's a wealth of public data sets that you can try using. So there's weather data, there's finance data, there's government related data, there's healthcare related data, and of course, Wikipedia related data. So all these public data sets are available for you to try and use. And because it's on BigQuery, you can imagine that a lot of these data sets are going to be in the gigabytes or more in size. So these are going to be very, very large data sets, essentially, for you to play around with. So with that, just at the top of the half hour, so thank you so much. If you want to learn more about BigQuery and BigQuery ML as well, I highly recommend this book. It's called Google BigQuery, The Definitive Guide. It's a great section. The bulk of it is around BigQuery, kind of how it works and how to use it. But there's also a great chunk, a great couple of chapters on BigQuery ML as well and how to use that in your particular production environments as well. So, and if you also like to kind of follow or subscribe to the subreddit for BigQuery, you can find the latest kind of news that people tend to post there. Great, that's it for me, and I'd love to take any questions that anyone might have at this point.
Thanks for that, Polong. It was really exciting to see such a whistle-stop tour through BigQuery and some of the facilities available on GCP, especially having that seamless interface between the client libraries and normal libraries that you'd use for an ML pipeline. So the way that we're working is the Q&A tab. If you open it at the bottom of the screen, you'll be able to see the questions that are there, and feel free to kind of submit some more questions. We've still got about 20 minutes left for the session, so yeah, maybe we can take a bit more of a detailed look into some of the some of the stuff that you talked about as well.
Great. Yeah. So I see the first question is, so why is AutoML better than human submissions? What does it do better? So I don't have, I should have included a slide on AutoML. It does a variety of different tests on training many different models. It also does feature engineering, also looks at seasonality as well. So it tries to kind of train a variety of models and to try to find which ones perform the best. And so for that reason, it's called AutoML because it's trying to do that. If you were to manually create those models, you could certainly do that as well. It would just probably take a person a lot longer to be able to reach that level. What we find is AutoML sometimes is used almost as a threshold or as a baseline. So a team may say like, oh, we could try to create a model for our particular business problem. But we could maybe start off with AutoML for like a budget of 1 hour or however many hours, and say, okay, AutoML has performed to this level. Now, given our data science team, do we want to invest time to try to improve that? Do we want to just simply take that as is, or try to establish how much in terms of resources would be needed in order to achieve better than that? So there's different ways in which you could use AutoML. It doesn't necessarily mean you have to use it in production. It could be used as a threshold. It could be used as a way to kind of compare with human trained models as well. So it's entirely up to you how you might want to use it. But yeah, the way that AutoML tends to work better is because it tries to create a ton of models and in different ways to be able to outperform. Typically, well, not typically, or generally, it just does very, very well. Okay, so I hope that answers your question. And I have another question here. It says, can we play around with BigQuery data from PyCharm without downloading it locally using Python? Yes, so PyCharm as the IDE. So you could use the client library, connect it to your Google Cloud project. So BigQuery data kind of sits, so the data on BigQuery sits in BigQuery in the data warehouse. So, and you probably don't want to be using something like select star all of your data from your data warehouse, right? So if you just simply do any kind of group bys or filters and then bring only the data that you need into your pandas data frame, then absolutely. So I would recommend trying that. So you don't have to download all your data out of the data warehouse. Highly advise against that. Leave it in there. Use SQL to make the best of the filtering, the group bys, so that you can really bring out just the data that you need to be able to play with in Python. Out of PyCharm or any kind of IDE, whether it's Jupyter Notebooks, you could also use RStudio. You could use other kinds of IDEs. That's no issue. Just have to have the right package, essentially. Okay, I'd like to ask how many projects are using BigQuery ML at Google? I don't know the answer to that question, sorry. So I'm not sure I'll be able to answer that at this point. So I'm gonna have to skip that, unfortunately, sorry. How do you implement different sampling techniques and cross-validation when training models use BigQuery? So there are ways to sample your data on BigQuery, though because the querying engine for BigQuery can scale up automatically and so quickly, you'll find that sometimes you don't even need to sample your data because you could actually just query your entire data set. But nonetheless, if you want to split into train test, BigQuery ML actually automatically splits it. You can find it in the documentation on how it splits it. You can automatically split it into train test for you. Cross-validation, you'll have to set up yourself afterwards, but you could do that all within BigQuery ML. So yeah, hopefully that helps. Next is on how exactly BigQuery leverages scalability and distribution to process big data sets. Behind the scenes, how it works in detail, I'm not going to be able to give a great answer. So I would leave that to maybe someone who knows the infrastructure and how that scales really well. So I'm not going to be the best person to answer that. So I'm actually going to skip this question, unfortunately. Sorry. Is it possible to share the BigQuery ML notebook links? So the link that I had kind of shown in the Jupyter notebook, I don't have that publicly available right now. It is using publicly available data. So you could essentially kind of recreate that if you were to rewatch the video, I'm not sure, but I'll try to find a way to put that online for you. But great suggestion. Can you share if concurrent data queries or BI data ML pipelines work with a fair amount of encapsulations for different consumers? Two parts. Number one is concurrent data queries. You absolutely can. There's a limit of the number of queries that you can run at a time for BigQuery. So you can check the documentation for that. But usually that's a good enough amount for most cases. For a fair amount of encapsulations for different consumers, I'm not too sure exactly what that means. It'd be great to follow up. You could feel free to tweet at me at Polong Lin if you want to follow up on that. How does BigQuery compare with other analytical databases? For example, ClickHouse, Elasticsearch in terms of processing speed. I'm also not the best person to answer that. I think there are some articles out there around this, so I would encourage you to take a look at those. Can BERT TF model work on Wikipedia text directly on BigQuery? That's a great question. I don't know. I haven't tried it, but please let me know if you are able to get that working. I've never tried it before, so I'd be actually quite curious. Please do tweet at me if you want to follow up with me on that as well. So great. There's like a whirlwind of Q&A questions, but feel free to ask if you have any other questions on Twitter, or I think I shared my LinkedIn URL as well. So either way, yeah, happy to answer more questions offline.